Plasma is a phase of matter or state of matter. So unfortunately, our schools don't. It's like I'm not sure why this is the case, but all children learn the three phases of matter, right? So, and what does this mean? So we'll take like water as an example. So if it's cold, it's ice. It's in a solid phase, right? And then if you heat it up, it's the temperature that typically sets the phase. Although it's not only temperature. So you heat it up and you go to a liquid, and obviously it changes its physical properties because you can pour it and so forth, right? And then if you heat this up enough, it turns into a gas, and a gas behaves differently because there's a very sudden change in the density. Actually, that's what's happening. So it changes by about a factor of 10,000 in density from the liquid phase into when you make it into steam at atmospheric pressure. All very good. Except the problem is they forgot like what happens if you just keep elevating the temperature.
You don't want to give kids ideas. They're going to start experimenting, and they're going to start heating up the gas.
It's good to start anyway. So it turns out that once you get above, it's approximately 5 or 10,000 degrees Celsius, then you hit a new phase of matter. And actually, that's the phase of matter that is for pretty much all the temperatures that are above that as well too. And so what does that mean? So it actually changes phase. So it's a different state of matter. And the reason that it becomes a different state of matter is that it's hot enough that what happens is that the atoms that make up, remember, go back to Feynman, right? Everything's made up of these individual things, these atoms. But atoms can actually themselves be, which are made of nuclei, which contain the positive particles and the neutrons, and then the electrons, which are very, very light, very much less mass than the nucleus, and that surround us. This is what makes up an atom. So a plasma is what happens when you start pulling away enough of those electrons that they're free from the ions. So almost all the atoms that make up us up and this water and all that, the electrons are in tightly bound states, and basically they're extremely stable. Once you're at about 5,000 or 10,000 degrees, you start pulling off the electrons. And what this means is that now the medium that is there, its constituent particles mostly have net charge on them. So why does that matter? It's because now this means that the particles can interact through their electric charge. In some sense, they were when it was in the atom as well too. But now that they're free particles, this means that it fundamentally changes the behavior. It doesn't behave like a gas. It doesn't behave like a solid or a liquid. It behaves like a plasma, right?